So it's very clear, power system is a complex interconnection of several generators, transmission lines, transformers, switchgears, loads, etc. It means to say, power system would be very simple if I have a simple generator and a load local. Moving to the portable generator put on for a certain functions or certain exhibitions where a local power is generated and met accordingly. That is the simplest power system what one could find. It is not the power system as such by its geometrical or geographical perspective. If we see a power system in its full-fledged form, it's a very complex interconnection of a variety of generators due to the resources available. Hydro resource, hydro generation, nuclear resources, nuclear fuel based, and thermal based, and renewable and alternative fuels, etc. All such generators are positioned at the centers where the resource is available, and that resource is captured and converted into electrical form by turbines and interfacings, whatever so. That converted form of electrical energy is interconnected to the grid and national transmission mechanism with the appropriate stepping up, stepping down with switchgear and making it to reach the destination to the end user. There are variety of end users, domestic, corporate, and industrial, any of such. Their subjective specifications must be met by the power system. Now I could get back to the power system being very complex interconnection of various generators, transmission line, transformers, switchgears, etc. and loads, meeting the expectations of the end user effectively, keeping the resources optimally utilized, planning for the proper balance of active power and reactive power is the focus of electrical power system. It is not simple generating system, it is a very complex interconnection. Definitely it is required. So moving to the next one, a different analysis required for a system operation. Why do we require it? As we interact with a different interconnection of generator, transformer, transmission lines, utilization, etc., there could be a fault, there could be a failure, there may be anticipated or unexpected events which are happening on the system. The system must be equipped with some measure so that such unwanted or unexpected instances or incidents one would occur, the system should have a chance to overcome and counteract on them. In that regard, the study of power system behavior, study and knowing the health of the power system become very necessary. It may be a simple approach, a load flow study if I initiate. Load flow study being study of power flow on the given transmission mechanism from the generator to the end user. How is that flow? Do any generator is burdened from that? Do any transformer is loaded and beyond its capacity? Do any transmission mechanism is stressed beyond its transfer capacity possible? Or is there any transmission line suddenly out due to which the other alternative lines are getting subjected to high work pressure? So this is how the state of health of the power system from the perspective of power flow is to be studied. Then that analysis is very necessary for us. Having known the given power system, its interconnection represented in a particular software or in the particular mechanism available and making it to function as it would be seen on real time. It means it is necessary to view the real power system which is geographically very wide covered area that we cannot fly and see during the requirement. It should be visualized being or sitting in an energy control center or a computer controlled center where all such instrumentation is perfectly performed to view the real power system on real ground. We can work it out where the power flow is occurring, where the line is stretched, which generator is loaded, which loading area is highly drawing the power. So how to balance these things, where there is an scarcity, where there is an excess, so this can be seen effectively. For that, analysis are required. Suppose if I perform a short circuit study analysis. Every power system operator who is controlling the power system sitting in front of a computer control in an energy center try to operate the system very effectively, making use of its skill set, knowledge, database available to maximize the performance of the system so that cost-effective operation is possible. But what may happen? Due to the fault, natural or accidental thing, transmission line subjected to fault. Due to their operation, due to accidental or a natural or any other calamities which would occur, because of which system gets obstructed by its functionality. Therefore, on whose open circuit, on whose short circuit, on whose failure any of such component, system need to be appropriately represented into the computer console or a program which is able to recognize the changes which have occurred right now due to the occurrence of such an incident should be worked out immediately, and analysis on such should be performed so that such an analysis would anticipate or such an analysis would give the remarkable outcomes such as what would happen really or what would have really happened, what has really happened, what for it has happened can be studied perfectly. Hence, it's very necessary to analyze the system. Like one example of short circuit study, I would say. Suppose stability analysis you would like to see. What do you mean by a power system stability? It is an ability of the power system to be intact in its operating conditions, initial conditions, what have been set, even after experiencing minor changes, major changes, system should be intact, able to cooperate, able to dissect, bifurcate the defectiveness of the system and able to retain the existing system in good condition. That ability and making itself able to be intact in the service is we call as stability of the system. Suppose system is not able to be intact in itself, on such occurrences, how do we say system is highly stable? The other aspect of it, if I go to security and reliability, how secured is the system for such faults repeatedly occurring, randomly occurring, or such stringent changes which are occurring on the power system? So, is the system is proof of such, having ability to counteract on such so that it is able to retain its working condition safer? One would be expecting that. Similarly, the reliability. How reliable is your system? What is the performance indices or performance index of the system? How best this could perform the expected expectation, meet the expected expectation of the end user. Like that, availability of a certain component for its intended service right in time. What is the guaranteed nature? That the system will be in place for service of particular load or particular delivery in spite of its committed activities. That reliability analysis, we call it as probabilistic approach of availability of a certain component for certain duty which is expected. All these studies must be performed in an energy control center wherein all the instrumentation which is equipped with the end devices telemeter the information to the center, and being in the center with a very high-end program where computer algorithms are written, programs will run continuously as a subroutine. They evaluate the state of health of the power system and give you the remedial action. One would take action on such analysis. Therefore, it's very necessary to analyze. When you want to analyze a system, necessarily it becomes a tool. What is the tool you are using? Some software, some simulating tool, some implementation of the real power system after being modeled, the component generator, transformer, transmission line, switch gears, loads, etc. in a proper manner, in a technical, scientific way. We have to represent them and we have to execute the program. For that we require representation of the power system in real ground, that we call as a single line diagram. Per phase representation of the three-phase system. It is the first phase representation of the real three-phase system, which is we call as single line diagram. So all these things come as very basic requirement. Once we are able to understand why power system is coined, a corporation is investing so much of money in business, meeting the expectation of the load and putting them in service. When the material resources are utilized, the maximization of this is nothing but the task of the power system, always keeping up the balance between active power, reactive power delivery, voltage level of the bus and the power factor of the system, etc. So this is a dynamic situation. It is not going to be stable. It's a dynamic situation that one-to-one, a conquer and win like that situation will be always there with the power system. So hence, it must be seen very carefully. Different analysis must be performed. And there are so many things to understand. the current situation of the power system, planning and designing for the future expansion, study of stability, state estimation, economic scheduling, and cost study extra. These are all the different aspects like a power engineer who is working in the energy system should be always put with the task what exactly would happen very next moment, very next day, very next week, very next month, how will be the variation in the load pattern, what will be the nature of the load, how we would meet that balance, how our generation is going to cope up. If not, what to do, borrow the power from the neighbor corporation, sell the power if it is in excess, if it is a problem, if it is a maintenance, how should I act? All these things must be appropriately be worked out. In that regard, proper understanding, proper planning, all such study and analysis are very necessary. Therefore, load flow is a very frequent operation, frequent analysis being done. This serves as a basic analysis of the given power system to know the current health of the power system. On whose state, further analysis, how is the current situation of generation, load, and structure of the power system? Do it require a modernization? Do it require capacity building, or it require control so that the cost effective operation is possible on whose model? It is like an first report what we get on the medical report of a patient in an observation, on whose observation the variation in the parameter can be assessed and appropriate corrections can be given by prescription by the experts. That this serves as one of the best report for us. Load flow study shall be performed, knowing the health and the factors which affect this, what, where exactly, and where and when, how all these things can be questioned and can be understood to work it out. Then there are so many definitions one would understand on this behalf. What is the power system? I was just interacting with is a complex interconnection of generators, transmission lines, transformers, and loads. I call it as integrated power system. It's very latest way of defining integrated. It's an integration of variety of generation mechanisms and transmission line, transformers, and variety of end users. Their specifications are tremendous and very typical in nature. Meeting their expectation to their satisfactory level is not that easy by the corporation. So the corporation always keep their targets and set their targets to respect to expectations so that it is able to fulfill those things in a very cost effective manner, for which lot of infrastructure, generating point, transmission layout, distribution, in installation, investment, acknowledgement, manpower, all those things must be incorporated to meet the expectation of such. Then next moving to the operating quantities of power system. There are so many important terms related to the operational aspects of the power system, physical quantities, measured or computed quantities, which are used to define, which are describing the current operating condition of the power system. It may include real power, reactive power, apparent power, RMS, phasors of the particular voltage, and other like this. So which are really electrical terms. I would otherwise say the best friends of electrical engineers are PQV delta. If we become friendly with these things, absolutely other part of the impedance, admittance, phase angle, all those things necessarily be associated with all these things. Therefore, the other part is inherent for the requirement. So we need not explicitly express that. It is required basically in other way. Then the steady state operating condition of the power system. An operating condition of the power system in which operating quantities that characterize it can be considered to be constant for the purpose of analysis. It means to say, whenever you perform a particular operation, the power system is expected to be always stable. The operator always want to maximize the performance. It would mean he try to avoid the turbulence, he try to meet the imbalances, he try to anticipate and control the actions on certain changing or certain changes of the particular variation so that system is brought back to the healthy condition. So for such analysis, when we do certain discrete analysis, till that end of the analysis, the quantities variation considered to be stable. In that way, steady state operating conditions means when the analysis started, till the completion of the analysis, the variations are not taken into consideration because it is expected to perform its operation, execute and show us the report or provide a result. Till that duration, steady state operation is expected. So this is how some of the parameter like steady state operating condition of the power system is also important to us. Some more definition, disturbance in a power system. As we were interacting, power system being very complex integrated mechanism, naturally due to so many equipments interconnected, chances of getting disturbed due to the failure of the component, due to the abnormal behavior of the component, due to the faults on the system, there could be a lot of or minor disturbances which affect the operational aspect of the power system. So therefore, disturbance in a power system is a sudden change in sequence or a changes in one or more parameters of the system or in one or more operating quantities. It's a very beautiful way of interpreting the disturbance. It is one of the sudden change in sequence of changes in one or more parameters of the system or in one or more of the operating quantities. Anything may be the reason for this. If those quantities are getting affected, it could be a disturbance. So it is just like a particular parameter stimulus for the system to change its behavior. So that system should be able to discriminate this change as a normal, as an disturbed. When it is a disturbance and unexpected, it should be brought back to the controlled condition by appropriate actions simulated from the particular energy control center. The disturbance can be small disturbance in power system, maybe a minor variation, which will not affect the system in large scale. It may be describe the dynamics of a system, maybe in linearized for a purpose of accurate analysis, etc. It may be minor, just a parametric change, a small change in temperature, small change in voltage, need not be that noticeable immediately. So we call it as a power system when we say state of power system, normal. Everything will be intact. No component is violating their operating condition. Everything is at a preset operating condition. When one or two components of the system become little deviated from the operating point, they have not crossed their maximum boundaries or minimum boundaries, a minor change is noticed, but still system is closed. We call them as an alert state. It's a minor disturbance, minor variation, which is not going to hamper the system in any mode, but there is a shift in operating condition that the minor disturbance would cause a minor defect. It could be a light fever. It is not a major effect or influence of major expectation on the health of a human being. Like a minor temperature which is noticed by touch by a human only. Like that is a minor disturbance which could be cope up or it can be overcome by just minor actions or minor remedial measures. What would be large disturbance in a system? It could be a failure. It could be a sudden switching action, or it can be a combined effect of such, which would definitely threaten the system, which would definitely modify the operating conditions, divert their attention so that the measurement and other calculations will change tremendously, and that large disturbance is definitely going to cause major changes in your operating control condition. So therefore, system get affected by these disturbances. So steady state stability of a system. When we say stability, basically we say an ability of the system to be intact in system's operating condition, where it is a small disturbance or a major disturbance, it should not lose its operating condition, able to swing back to the operating condition. If we say it's an ability of the system to be in service, in fact, after having experienced faults, disturbances, that ability we call stable or stability of the system. We would like to be stable. We would expect it to be stable in its operation. Suppose the system is very huge, massive experiencing or massive faults are being experienced. We call them as a transient. In a fraction of a second, thunderstorm like things happen and switch away. This we analyze as a transient stability of power system. System should be able to cope up all these things because these are quite natural on the system as it is in service. So 24/7 like service, it is expected. Anything may happen, but ability of the system do really matter whether system is able to cope up with such failures, such disturbances or not. So transient stability is another important aspect of the power system. One would see any major switchings in a microsecond scale of time should definitely damage and disappear. So I always compare these stability aspects and transient stability aspects as human health and the such massive attacks on a power system like a heart attack or sudden failure or getting lost, such controls, I compare them so that I could definitely correlate those things, a proper monitoring, proper analysis, proper diagnosis, proper medication to such patients on observation would definitely make the patient health to be improved, or patient health and that such observation could make the estimation of the proper health of the patient can be done. Similarly, such observation for stability aspect is highly necessary. Power system definitely requires such observation on its for its normal working conditions. Definitely, I would continue with the power system stability aspects and its definition, how exactly stability is seen. Suppose stability of a power system is threatened basically because of mismatch in active power delivery and reactive power delivery. System will not be able to keep its active power generated to meet the requirement and losses. Definitely, frequency is going to indicate you the oscillation. So frequency flicker, frequency oscillations indicate that the active power mismatch is really causing a worry. Then this active power mismatch cause stability threats. Suppose if the system is not able to cope up with a certain buck voltage, voltages are flickering, not able to cope up with a certain voltage level. Therefore, that's an indication of a reactive power imbalance in the system. So the health of the power system is monitored from that objective. In that context, equilibrium of a set of power system equations, P balance, Q balance, if we are not able to meet, the indicators F and V do that work. So if we are not able to retain them in a proper range, it's an indicator that stability of the system is being threatened and security, reliability aspects will be compromised very soon. Therefore, it's very necessary to see to that whatever is the configuration of the system you have done, so many generators, so much of infrastructure, so much of variety of loads, so many objectives with put men, material, resources, etc. should be synchronized in a very proper manner with a set of tools and available algorithms and energy control center can only make the things better. But the maximization of the performance of the system is the ability of the system operator only. So therefore, it's the complete dynamics of the machine which one would experience during the faults only. Therefore, keeping prepared for such occurrences is a knowledge data set which would help to take the decisions in such diverse manners or diverse situations. Therefore, stability is very important. It is highly defined in one of the former books, Anderson book, and forward you can just see how exactly that response stability is worked out. Then some more overview, how power system is put into service. Power system is put into service with so many objectives with a goal. So field power system in proper operation, proper balance is done. Emphasis is given on transmission system because transmission system do suffer the often faults, failures, breakdown, so many things. So they need to be worked out appropriately. Proper protection mechanism must be provided such that the monetary loss to the corporation shall be minimized. So introduce basic power flow concepts to smart systems example so that system can be put in operation. So these are all the variety of integration into a system. Their proper coordination and observation operation is very necessary. So all power systems have three major components. I was just defining transmission, generator, load, transmission mechanism, distribution, etc. And generators fall with the generation activity, load fall with the consumption of electric power, transmission distribution work with the transfer of power from one to the another end. So many transmission lines with a different kV level for a short, long, or a medium range of work, medium MVA transfer capacity, large MVA transfer capacity are put with. It means all together interconnected such that everything will work hand in hand to meet the end user's effective way of its usage or meeting their subjective specification effectively. This is a small example how that power system is needed or need a simulator to analyze. So you just see a power word simulator. A case study has been taken from a student version of the power system simulator with the three buses where we have different generators located, different loads were mentioned, different transmission lines were interconnected, and the transmission power flows were worked out by simulating the power system in that particular tool so that the actual megavolt ampere transfer on each line, the generation at each generator, load what exactly it is consuming, loss what is happening can be viewed from this simulation. This simulation or such simulator tools really help the power system engineer to work with the particular power system which they are likely to plant or implement. Before they implement it, they can anticipate what is going to happen or what would be the remedial measure, or if already a system is put in service, its representation, if it is done appropriately, whose study analysis on such would give you tremendous output so that control can be done in an effective manner. And you can minimize the losses, we can work out effectively, make a cost effective working of the system by the use of such software. So these software, education software which I have taken works really effective. Such education software, my power, we will be using in the laboratory to work with the numerical problems of our particular subject. So this is just to show you how exactly a power system simulation tool help the student power system engineer to study the power system and try to maximize the performance, try to plan and control and operate effectively is worked out. So this is one system where balance system is noticed. No line is red hot, means no component is having neck to neck challenge of its capacity. Every component is safe, intact, and two areas were just bifurcated, area 1, area 2, where set of generation, set of load were interconnected by transmission lines. The next one which I have shown, the overloaded transmission line. The same example, due to the case study that a huge power draw is going on, the generators were stalling. They are generating more and more power to meet the requirement because of automatic mechanism we called as automatic generation control, AGC, which tried to balance the active and reactive power generation with the demand with the losses which would occur in the system. Then power which is generated has to be pumped to the grid, to the transmission mechanism. The transmission lines find themselves limited because they have a particular conducting material which is put with the conducting material on a pole to pole have their own limitations of MVA transfer. The transfer capacity of which is limited by conductor current amperage rating. So they cannot transfer the capacity that they can definitely do beyond its rating. Therefore, this shows a case study when there is a high power draw of a particular loads, the generators, even though if they are capable, the transmission line pose the constraint. They cannot meet your requirement because of transmission ability constraint only. This would definitely be benefited by the power engineer, the students, the educator, so that such an simulation, certain load is drawing a high power on a certain day or a certain season, one would see the remedial action for this is making the system routed properly, cutting the load or making a rerouting of the load from that particular different generator to the particular load, etc. can be intelligently planned. Therefore, my intention here is to emphasize the need of such simulating tools to understand the power system very effectively and operate it very cost effectively was my focus. So this is just to show a snapshot of the particular view. Then moving to the particular balance, there are so many other constraints how the power system should operate. Power balance should be there, basic power control should be there, transmission line limits are the challenging limit one should operate. These are the factors which definitely one would see. Under the power balance, all the things must be in a balanced condition, try to be in appropriate way so that system will be in steady operation. Else system will be always in turbulence. When system is always in turbulence, definitely it cannot be maintained stable. People in and around will be striving hard to keep it up. It doesn't work effectively. In that way, basic control of how it should be done. So it should be worked out, and transmission line limits are the basic limits. We cannot transfer the megawatt, whatever I generate at a certain generator to the load wherever I have. There is a limit of a generation, a limit of transmission on each line. Transfer capacity poses a very basic limitation. And even the transmission line mechanism is very perfect, generation is inadequate. Even we cannot meet that situation. It is just like a cooperated operation. Coordination among the generator, transmission line mechanism, and transfer load, etc. has to be appropriately planned. See to that it will not make any one of the systems affected by its undue overriding of the other.